Good morning.
Good morning.
We'll just get started. It's March 8th. Oh, yeah. More exponential equations. This shouldn't take too long. We did the lion's share of the work yesterday as far as learning how to solve these is concerned. But there's a little bit of extra kind of spice to them today, which is why I elected to leave them out of yesterday's lesson. So I hope you got last night's done. That was, of course, the goal, so that you wouldn't have work piled up. So let's get right to it. No concept stuff today, because you already know how to do it. It's just the problems get just a little bit harder today. So we're going to just do 5 examples and call it good, however long that takes. So our first one is 1,240 equals 490 times 1.05 to the power of x plus 400. So what we learned yesterday still applies. The same exact number one thought from 24 hours ago. Do you remember what it is when it comes to these? Say it again. You get the power by itself. That is not going to change. That's going to be the thing that will immediately separate a passing quiz from a failing quiz. Is, do I remember that this thing right here is called the power? Note that the 490 is not part of that, right? Only the 1.05, the thing that's attached to the exponent, is part of the power. So just following basic algebra, what's the first thing we're going to do? No. Subtracting 400 is always how we would solve an equation like this. If I gave you 1240 equals 490m plus 400, you can't even try to tell me that you would divide first. So follow the basic algebraic knowledge that you have, and that is to add or subtract away first and then multiply or divide second. That's always how we're going to get the power by itself. So we're going to subtract 400 first, which is going to give us 840 over here. Like such. Now, our calculator is going to help us make a decision with this next step, and that decision is going to be, am I going to get a good number or am I going to get a bad number? That if the decimal is a friendly decimal, then I'm going to just carry it down. It's easier to do it that way, quite frankly. But if it's an ugly, evil decimal, then we're just going to leave it as a fraction. So I'm going to take on my calculator and divide 84 by 49. And you can do the same. And what do you see? Yeah, I don't see anything good. I don't see anything that I'm attracted to, meaning like if it said 1.75 or 1.725, I'd be like, oh, I'll just take that and run. But we don't like this. And so we're going to leave the left-hand side as a fraction. And you don't have to reduce the fraction. I, however, obviously am going to take off the zeros. That's a simple thing I can do. But you could also divide them by 7, but there's really no benefit because the calculator is going to help us anyways. So just kind of reduce as you see fit. But again, do not put a ruined decimal down there. You greatly decrease your odds of getting the correctly accurate answer that we're looking for. So leave it pure. 84/49. You could leave it as 840 over 490. It's all the same. Equals 1.05 to the power of x. So we've done job 1, and that was to get the power by itself. What's job 2? Same as yesterday, 3 words. Log both sides, right? Just get used to saying that. Log both sides, log both sides. And remember that as we log both sides, we're doing it with a purpose. We're doing it because there's a benefit. And so I'm going to log the left side. No benefit to using any particular flavor of log, so we'll just go with the standard base 10 log here. So we have on the left log of the left side, 84/49 equals x times the log of 1.05. You guys have any questions so far? All right, and then there's only one more step to do. Again, just think like an algebra student. It might look like all fancy, but at the end of the day, It's really just number equals x times number. What would we do to solve for x? Divide both sides by the number that's attached to x. Specifically in this case, that is the log of 1.05. So we want to divide by whatever is going to get x by itself, like such. And at this point, then we would interact with our calculator. Now we have already to determine that we should have left that thing as a fraction, which we did. And now we're definitely going to leave the heavy lifting to the calculator. So at this point, each of us, your calculator is only as useful as your ability to use it. You know, I know people who take like that free calculator you get out of a box of Frosted Flakes, and they know how to use it better than someone with a $100 calculator. So if you understand how to use parentheses and how to put in logs, then your calculator is perfect for you. All right, so let's all take a moment and type it in, and then we'll hopefully come to an agreement as to what the answer is. I wound up with x is approximately equal to 11.05. Yes, it's 11.047, blah, 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 but the 7, of course, rounds the 4 up to a 5. And as I'm sure you learned last night or yesterday, whenever you finished your assignment, you don't get to round poorly, right? That's not something that we just shrug off like it's not a big deal. We round well. That's what we do. Any questions on that one? Everybody get that? All right, good. All right, let's head to the second one. I tried to pick problems that were not redundant, you know, like it's not going to be the exact same thing every time. So let's go again. 143 equals 660 times 0.955 raised to the power of 0.56x minus 77. Give you a minute to write that down. Well, we'll give you 10 seconds to write that down. Have a sip of coffee, and then we'll move on. What do we do first? Yeah, add that 77 across, and 143 plus 77 is 220, I hope. So I get 220 equals 660 times 0.955 raised to the power of 0.56x. What's next? Pi. Right, and again, take a moment, unless you're really good at mental math, which some of you can look at that and already tell me what that is. How many of you can see that 220 is directly and exactly 1/3 of 660? So if you can see that, you already know what's coming down the pike. You know that the left side is going to equal 1/3. And you also know that the decimalized version of 1/3 is something that we want to stay as far away from as possible, right? So we're going to leave the left-hand side. Again, if you want to leave it as 220 over 660, leave it. You want to take off the zeros and put 22 over 66? Great. You want to reduce it all the way down to 1/3? Great. They all equal the same thing. The one thing we don't, again, want to do here is put some ghetto decimal. It's not going to do us any good. Could we get it right? Yeah, there's a pretty good chance we might. It's not worth it, though. Leave things pure. So we have 1/3 equals 0.955 raised to the power of 0.56x. And then from here, this ought to look relatively similar, I think, to what you're used to. What do we do next? Log both sides, log both sides, log both sides, those three sweet words. Thank you, Jasper. So we log both sides. And as we log the left side, we just get log of 1/3, you know, whoop-de-doo. But on the right side, we get 0.56x times the log of 0.955. Any questions to this point? Now I think about this and I think to myself, how could I do this in as few steps as possible? So the idea is that I want to say, how can I get you by yourself? X, there you are. I put a red box around you just to highlight you. Say, I want to isolate you. So there are two things, exactly two things that we have to kill on the right-hand side. And how will they both be killed? By division. Right, now this is something new for today, and this is where you just have to make a choice. Like, do I want to listen to my math teacher and not mess this step up, or do I want to just get lazy and be the kid that wanders up to the desk and says, well, I don't know why I got this wrong? You're going to need to be really, really careful with this next step. So we are going to divide both sides by two things at the same time. We're going to divide on the right-hand side, obviously, by 0.56 times the log of 0.955. We're also going to divide on the left side by 0.56 times the log of 0.955. You don't necessarily have to show all this work. I mean, this is an obscene kind of early in the year algebra 1-ish amount of work that we're showing here. So I would understand if going forward you don't show in as much detail perhaps as what I'm showing. But this is the killer step. And again, this is the step where you just have to make the choice. I can't make it for you. Do I want to get this right or do I want to get this wrong? How we type in this next step is critically important. And so I'll show you I kind of wish I had an overlay that would show what my calculator looks like. But I'll show you generally what yours should look like, assuming you're using something relatively modern, like either a TI-30X2S or a TI-84 or something like that. Again, if you've got some old ghetto thing, you and I will probably have to visit about how to make that work for you. Those older calculators without the display screens, you know how on yours, how you can like backspace and move the cursor around? The inability to do that makes problems like this uber difficult. You might want to consider the $13 investment if you have a ghetto calculator. All right, so having said that, let's assume you have a good one. And when I type in my first part of my problem, I'm going to type in log in my screen. I'm going to write it up here exactly what my screen is going to look like. It's going to say log parenthesis, and then I'm going to type in 1 divided by 3, and then I'm going to close the parentheses. You might think, well, what's the big deal? Well, this is the big deal. Then I'm going to hit divided by again, and it's going to look like this. Your screen should also look like this. This is the step, and I'm going to write these parentheses in red so that hopefully you go, I was here today, I heard this, I understand the importance of this. I want all of this to be what my calculator divides by. And if I'm not careful, if I don't add a set of parentheses, it's not going to do that. It will only divide by the first thing and then multiply by the second. We don't want that. So what we say to our calculator is, okay, I'm coming in right now. I'm going to add a left parenthesis. You need to do that too. Because I'm saying now to the calculator, I got a whole bunch of stuff I need you to do before you execute that white division sign on the board. Hold off, order of operations. Do my parentheses first. And in the parentheses, I'm now going to type in 0.56. Notice I don't put the 0 when I'm interacting with my calculator. The 0 is just something that we would generally do if we were writing work and stuff like that. So the 0.56 is fine. And then I'm going to put times. So now I've got my little times sign on the board. And then I need to do log. Just trying to stay caught up so I can copy my screen exactly. Note now that the calculator is going to open a new set of parentheses. I've color-coded them for your benefit up there on the board. The white parentheses, the white parenthesis that you see belongs to the current logarithm. And in that logarithm, I want to put 0.955. And I'm going to close that down. Now, the red parenthesis that I started to tell my calculator, this is all in the bottom of the division problem, I now need to seal that one off, and that's this one. Mark my words, if you don't put those red parentheses in, you'll miss these problems exactly 100.0% of the time, because your calculator will do division and multiplication from left to right, which is not what we want it to do. Your calculator will do exactly always 100% of the time what you ask it to do. You just have to know how to interact with it. And that's where the second set of parentheses. So you basically at the end of your input have parenthesis, parenthesis. The first one shuts the log off, the red one shuts the bottom off, and then if you hit enter, you get your final answer, which if we all played our cards correctly, we should have all gotten the same thing. X is approximately equal to 42.61. It's supposed to be a time sign. I was trying to, I'm sorry, I knew that didn't go well. I was trying to mimic what the time sign looks like on a calculator. So here, I'll just put a time sign. I don't know what I was thinking. I was getting crafty at 8:07 in the morning. You can do it in steps if you want to. If you don't like this way, which for some odd reason, I guess is fine, you could do just this portion first and make sure you hit enter and then divide by this portion again. So you can basically treat it as two separate division problems.
So we did it. The first time I did it log 1/3 divided by log of 0.955.
And then you hit enter.
And then I did divided by 5/6, and that gave me.
Right. And so as long as, like I said, as long as you treat it as two separate division problems, and the order, good question, Royce and Jared, the order that we do, I'm running out of colors here. The order that we do these two divisions in is irrelevant as long as we treat them both eventually as divisions. That's the key. So I would say that if you should either implement the double parentheses like this big red batch to say, hey, calculator, do all this stuff real quick for me before you divide, or just acknowledge that you have to divide, follow up here. Eventually, this blue division problem needs to take place, and this green division problem also needs to take place. And by doing them sequentially like you did, that would also work. The one thing that would not work is to type it in literally directly as the problem says. If you type in log of 1/3 divided by 0.56 times the log of 0.955, you will miss it 100% of the time. Got it? Is everybody okay? It's like, do we all have a way now that we understand how we can get to the right place? Great. Okay. So watch out there, tread cautiously. Next one. Step one. Subtract 480, which results, of course, in 600. Next step. Yeah, and this is again where the calculator will help us decide how we're going to proceed. So if I divide 600 by 420, I get another decimal that I am no way interested in putting on my paper, right? 60 divided by 42 is a mess. It's a train wreck. So we're going to leave it as just a fraction. And again, I implore you, just understand that fractions, as long as you understand what equivalent fractions are, then it doesn't matter. Reduce it, don't reduce it. The calculator is going to do all the work anyway. So like I could just leave it as like 60 over 42. Whatever. Just take off a 0. Divide them both by 6. Don't care. And the answer to this next question just doesn't change. It's those same 3 words. What's the next step? Log both sides. And as we log both sides, we need to be aware of the fact that we're doing it for the purpose of getting this thing in the red box down onto the ground where we can attack it. So as we log both sides, we're going to have on the left side the log of 60 40-seconds. And on the right side, we're going to have, watch out, watch out, watch out, x plus 1 times the log of 1.04. Bless you. Note the parentheses around the x plus 1. Again, I'm trying to do my best to not put you to sleep and at the same time to tell you things that are important. And here it's important that you put the x plus 1 in parentheses. Otherwise, you give the reader of your paper or your calculator the illusion that the 1 is attached to the log and that the x is detached. the x plus 1 travels as a package deal, hence the parentheses. So thinking about getting x by itself, what has to be the next thing that we do? You cannot subtract by 1. That 1 is not free to move about the cabin. It is, as you've seen in math before, when something is bound up in parentheses or absolute values or anything like that, it's not free to move about the cabin. How could I make those parentheses not have a reason to live?
Can you just do log 65 by 42 divided by log?
Yes.
1.04, and then
Yes, and that winds up being the algebra of it right there. It has to go in that order. The first thing that has to take place is you must divide by log of 1.04. And again, Royce is asking good questions that tell me that he's ready to maybe move a little bit faster than my snail self is moving right now. That is to see this kind of through that set of lenses to say, what am I trying to accomplish? Well, if I divide by the log of 1.04, the x plus 1 is now free to move about the cabin. His parentheses no longer have a reason for existence. He just sits here now and says, there I am. Thank you for getting rid of my parentheses. I don't need them anymore. And so, yes, like Royce said, we could just type in log of 60 40 divided by log of 1.04, and then, of course, hit minus 1. So let's all proceed with that and make sure we get the same answer. Anybody want to read theirs? Tell us what they got. That is correct. 8.09 is perfecto. I'm going to bypass one of my examples and just head to the very last one. Okay, so instead of 5, we'll wind up having done 4. I believe that was the third. So I think we'll be okay if we just skip number 4 and head to number 5. 4 and 5, looking at them now, I think we'll accomplish the same objective. So let's head. Oh, I don't know, 8.09, I think.
Yeah.
Is that what you got, Carter? Yeah, boy. $8,600 equals 8,010 times 0.98 to the power of 0.5x minus 2 plus 3,100. Step 1 and step 2, in order, what are they? Subtract and then divide, right. And so using your calculator, you can save a step here. If you just type in 8,600 minus 3,100, hit enter. That's really important, order of operations. Hit enter, and then hit divided by 8,010. And for the 4th straight time, we see a decimal that we want no part of, right? So we're going to, this would have been 5,500. And then we're dividing it by 8,010.
I don't think 8,000.
But we're subtracting 3,100. So 5,500, and then we have to divide it by 8,010. Stop now and ask if you have a question as to where either of those numbers came from. One thing I can do real quick, and I would always do this to save my fingers the hassle of having to push more buttons, is if I see 2 numbers and a fraction that end in a 0, I'll just take those dumb zeros off. And maybe we could reduce this more. I don't even know, and I don't even care. I'm gonna leave it like this and then set it equal to 0.98 to the power of 0.5x minus 2. And for the 4th straight time, the answer will be the same. What is the next step? Log both sides. And as we log both sides, sorry, Beckett, I'm putting you to sleep there, buddy, so I'll try to do better. We're gonna have on the left side, the log of 550 over 801 is equal to parentheses 0.5 x minus 2 close parentheses times the log of 0.98. I can't help but think that the color helps me to accomplish my mission. Those red parentheses are very, very important. And again, let's try to think quicker. And you can go at Royce Breeden speed if you want here. I mean, you can think about, there are literally exactly 3 things that I have left to do. If you want to, what's the first one that we must do? You must divide by the log of 0.98. After that, what is the next thing that you would have to do? No. You must then add 2 to both sides. And then after that, you would divide by 0.5. There are 3 things that have yet to go, and they must be done in a very particular order. So I'm going to go a little bit slower this time. So here's what it would look like. I'm going to have log of 550 over 801 divided by log of 0.98. I'm a little scared as to how to proceed here. I don't want to lose anybody. So equals 0.5x minus 2. Note that the red parentheses have disappeared. Why? Because I don't need them anymore. That was the entire point of dividing by the log that made them necessary. And then I hope from here you can see the algebra of it, right? To get x by itself, logically, the next 2 steps would have to be to add away the 2 and then to divide by 0.5. So what the answer winds up looking like this is what I'm going to type in my calculator form. We're going to have log of 550 divided by 801 divided by log of 0.98 plus 2. And right here, it's very important that you write down or that you enter on your calculator, hit equals. You must force the calculator at that point to hit equals, otherwise it's going to divide prematurely, which we don't want. So then we hit enter, and then we divide by 0.5. All right, so let's all try our hand at typing in that nasty, complex beast of an expression and see if we get the same thing. Get anybody have it? 41.22. That 1 rounds up to a 2. That's all. Then you typed in something wrong. You want me to look at it? Do you guys have any questions? The key to this today is obviously you have to know some basic algebra. You have to know like some, when do I add, when do I divide, that kind of stuff. Know your order of solving equations. But the real kicker is you got to know how to use that calculator. And if you're trying to use the one on your phone, a bad move, man. Those things are not designed for this. Okay, they're designed for helping people compute a tip at a restaurant or figure out like sales tax on a jacket when they're trying to decide if they could buy it, not calculations like this. So if you're rocking an old iPhone calculator or your Samsung Galaxy, you might want to consider, again, $13, $12, $15, make a trip to Walmart, get you a good one. It'll help you. All right, then.